All right, and in this lesson we'll talk about what does area represent in one of these graphs. So the area of velocity or the area of the acceleration graph, what is that going to tell us? In the previous lesson we used slope, and today we're going to use area. To review, make sure you know that the area of a triangle is 1/2 base times height, and the area of a trapezoid is here's one way to represent it. Let's find the mean of the two heights. The mean of the heights times the base, because if you take the short height and the long height, their mean is going to be halfway between them, and that makes a rectangle. So this is really just base times height of a rectangle. If you travel at 10 feet per second for 5 seconds, how far do you travel? Well, that's an easy question, but let's look at how it appears graphically. Let's draw how is the distance represented in the velocity graph. So velocity is in feet per second, seconds, and we're going for 5 seconds at 10 feet per second. So there's the velocity graph, and we know that we're going to travel 50 feet. 5 times 10 is 50. Where does 50 appear in this graph? If we can find 50 appearing in this graph, that shows us how we can go from velocity to position. So if we just look at this, and we see that distance equals rate times time, that's going to be 10 times 5, and we get 10 feet per second times 5 seconds. And we can see how the units cancel, and we're left with 50 feet. Where does 50 show up in the graph? It shows up as the area, which is, if we look at area of this rectangle, it's base times height. The base is 5 seconds. The height is 10 feet per second. And we can see the same thing happening. 50 feet is the answer. So now we know how to move up the levels of rates. If we look at position, velocity, and acceleration from the previous lesson, we saw that to move down one level, we use the slope. And here we can see, at least from velocity to position, we used area to move up. And it turns out area will move us up whichever level we want to move. All right. Find the position graph. So here we're given a velocity graph, and we'll use area to find position. And just to keep them, to make sure you're always visualizing it the same way, even though we're given velocity, let's put position up here. So it's always going to be position, velocity, acceleration, and that will help you remember whether you're moving up or down a level. And if you're moving up a level, you know you need to use area. If you're moving down a level, you have to use slope. Oh, and I guess I forgot to give you the graph. There it is. So let's make a table, and we're going to find areas: time, velocity, and position. 0, 1, 2, 3. The velocity at t equals 0 is 0. At t equals 0, velocity is 0. And then we go 1, 2, 3, just reading these values. Position. Here, we have to be given the initial position, and we were given the initial position of 0 feet. So we know the position is 0. Now we need to know, if we find this area, then that's the distance that it traveled. So we're going to go find the area of this triangle. The base is 1, the height is 1, and we're going to have the starting position plus 1/2 base times height, and that's how we get 1/2. Then we're at 1/2 feet. We're going to add the area of the next region, which is the trapezoid, and so that's going to be 1 height 1 plus height 2. 1 plus 2 over 2 times base, which is 1. And we have 3/2 plus 1/2, that's 2. And then we've traveled 2 feet, and we're going to add the next area, another trapezoid. So that's going to be height 1 plus height 2. 2 plus 3 over 2 times 1. The base is 1. It's not 3, it's only 1. 5 over 2 plus 2, and that's going to be 4.5. So we have found positions, and now we can just graph those, and we'll have the position graph. Seconds, and then we're going to do 0, 0. I'm reading time 0, position 0. Time 1, position 1/2. At time 2, position of 2. At time 3, position of 4.5. This goes up to 5, and that's in feet per, that's just in feet. All right, and we can describe the motion of the object. If we just look at these two graphs, we can say the object starts at a velocity of 0 and ends at a velocity of 3 after 3 seconds. Its position starts at 0 and ends at a position of 4.5 after 3 seconds. Find the velocity graph. Here we're given acceleration, and we can just find areas like we did in the previous problem. So, pause the video and try that one. We're trying to find velocity, and I just put position there to remind you that that's one of the levels, and then we'll go down to acceleration. And we need to look at time, acceleration, and velocity. The acceleration at 0 is 0. The acceleration at 1 is 2. The acceleration at 2 is 4. And the acceleration at 3 is 6. Then to find the velocity, we're moving up a level, so that means we need area. And the area of this is 1/2 base times height. We also know that 0 feet per second is the initial velocity, so we put that there. And let's find the area after 1 second. The area is 1/2 base times height, so 0 plus 1/2 base times height, and that'll be 0 plus 1. Then we go 1 plus. Let's find the next area. So that's going to be a trapezoid. We have 2 plus 4 divided by 2 times the base is 1. And that'll be 6 over 2 is 3. 3 plus 1 is 4. And the last trapezoid, 4 plus 6 over 2, and the base is 1. We have the previous position, so this is 10 over 2. 5 plus 4 is 9. Now we have points of velocity and values of velocity. So we know at, and that goes up to 10, this is seconds, and that is feet per second. At 0, we go to 0. 1 goes to 1. 2 goes to 4. And 3 goes to 9. We can describe this motion just by describing acceleration. What's happening with acceleration? It starts at 0 and it goes to 6 feet per second squared over 3 seconds. And we can say that the velocity starts at 0 and increases to 9 over the same over 3 seconds. Alright, find the position graph. And we're given velocity. Pause the video and try this one. Find position given velocity Alright, so we need the first region is, oh not yet, we have the initial position is 2, and that was given in the question. At 0 times 0 we have 2 feet, and then is 2 plus. Let's do the area there as 1/2 base times height. Half of 10, 5 plus 2 is 7. And then we'll do the next area is 7, we're going to have 7 plus the next area. 5 plus 15 over 2 times the base is 2. 20 over 2 is 10, times 2 is 20, that's 27. And then we have 27 plus, just a rectangle, so it's 2 times 15, and we get 57. And this is in feet. So we just plot the points, and we go 0, 2, 2, 7, 4, 27, 6, 57, and there's the position function, and we'll stop there.